Today's topic is different protocols present in transport layer. The different protocols present in transport layer are UDP and TDP, User Datagram Protocol and Transition Datagram Protocol. The simplest unreliable transport layer protocol in the internet is called the User Datagram Protocol. UDP is a connectionless unreliable transport protocol, whereas TDP is a connection-oriented and reliable transport protocol. The next shows the position of TCP and UDP in the transport layer. Next is the features of transport UDP. The features of UDP are it is a process-to-process communication. Here, the communication is done process-to-process instead of host-to-host communication with the help of port numbers. It does not add anything to the service of it except for providing process-to-process communication instead of host-to-host communication. It is the simplest protocol that involves minimum number of communication mechanisms. It also uses port numbers. Some port numbers are well-known port numbers and some are reserved and some are normal port numbers which we are using in our systems. Next, connectionless service. It provides connectionless service. That is, if client wants to send a message or wants to transfer a data to the server without any making connections, just like a postal service. For connectionless service, there is no connection is established at the sender and the receiver, which can add delay. Next point is unreliable. UDP is unreliable because the packets may be lost or delivered without of order. Here, no guarantee for delivery and no protection from duplication is done because it does not bother about how the data loss of data, and also there is no order and no sequence number given to the packets. The next comes flow control. Here no flow control mechanism is used. In UDP, flow control mechanism is not used. Next is error control. Here you are using checksum for the entire user datagram. It performs very limited error checking mechanism. Next comes congestion control. UDP can blast away as fast as desired, so it does not provide any congestion control mechanism also. If you have any limited error checking capability, and it is also doesn't uses buffer, no buffering before the transition. UDP accepts data and transmits immediately, that's why there is no need of buffering here. It is a very simple protocol and it can be used with minimum overhead. UDP is used when process need to send a small message without any issues of reliability. It is a full duplex concurrent transfer can take place in both directions. It is a good protocol for data flowing in one direction, suitable for unidirectional flow of data. It is a simple, suitable for query-based communication also. These all are the features of the UDP. Next is UDP header format. Here it consists of header and the data. The header length is of 8 bits and the remaining bits of data. The complete length of the data is of 32 bits. Header is divided here. UDP protocol are called as user datagram, which contains a fixed size header of 8 bits. UDP header contains 4 main parameters: source port, destination port, length, and checksum. Source port. This is a 16-bit information is used to identify the source port of the packet. Destination port. This is also an 16-bit information used to identify application level service on destination mechanism. Next is length. The length field specifies the entire length of UDP packet, including header. It is also a 16-bit field. The actual size is 2 to the power of 16. That is maximum number of data can be stored is 65535 bytes, 65,535 bytes. The minimum value is 8 byte, that is the size of UDP header itself. The length, here the length field consists of header along with the payload. Here the payload is the pure data coming from the upper layer. Header length is of 8 bits plus the payload length is of 65527 maximum. Here the maximum port numbers are from 0 to 2 to the power of 16 minus 1. that is 0 to 65,535. From this port numbers 0 to 1023 are well-known port numbers, and some are the reserved and some are normal port numbers which can be used in our system. The another field is checksum. This field stores the checksum value generated by the sender before sending. Checksum is used to detect error in transmitted signals. When checksum field cannot contain any value, it is made zero and all its bits can set to zero. The checksum field consists of UDP header plus UDP data and also the pseudo header of IP. The pseudo here represents the not entire value of IP address. It is if here it takes the fixed values of IP address from the network layer IP addresses. Here the checksum is like an unique hash value. The unique hash value is sent along with the data whenever receiver receives the data. When receiver takes all three values of checksum, again calculates the hash value. If this hash value and the hash value sent by the sender is matched, then there is no error. Else there is some error in the data. This is about checksum. Checksum is used to detect errors in transmitted segment. In sender, at the sender, it treats segment contents, includes header fields, has sequence of 16-bit integers. Here, checksum performs addition in one's complement sum of segment content. The sender puts checksum value into an UDP checksum field. Across the receiver, it computes checksum of receivers received segments. It checks if computed checksum equals checksum value field. If it is no, error is detected. If it is yes, no error is detected. This is about the header of UDP. The next is applications of UDP. The applications of UDP are: it is suitable protocol for multicasting, used for routing information protocol, used for real-time applications, traceroute, timestamp, and conferences. In detail, I will explain about the applications of UDP. The simple, unreliable transport layer protocol in the internet is called the user datagram protocol. UDP is a connectionless, unreliable transport protocol. It does not add anything to the services of it except for the provided process-to-process communication instead of host-to-host communication. UDP is suitable for process that requires simple request-response communication with little concern for flow and error control. It is not usually used for a process that need to send bulk data such as FTP. UDP is suitable for a process with internal flow and error control mechanism. UDP is a suitable transport protocol for multicasting. Multicasting capabilities are embedded in the UDP software but not in the TCP software. UDP is used for small route updating protocol such as routing information protocol. UDP is used for some route updating protocols such as routing information protocols. And UDP is used in conjunction with the real-time transport protocol to provide a transport layer mechanism for real-time data. These are the applications of UDP. Thank you.